So our today's topic is conformations. So first of all, what do you mean by conformations and conformational analysis? So conformations are nothing but different spatial arrangement of atoms that result from rotation about carbon-carbon single bonds. So when a molecule contain carbon-carbon single bond, and if that bond going to rotate, after that rotation we get different types of compounds or different types of isomers, and that isomers are called conformations. So these different conformations are also called conformational isomers or conformers. As you can see here also, there is a rotation of carbon-carbon single bond. So to understand the conformations, we should understand two projection, or we can say two projection formulas. Now first one is Newman projection formula and second one is Sawhorst projection formula. Now both these formulas are very useful to understand the conformations. So what are these formulas? Now these formulas are nothing but representation of stereoisomers. जैसे आपको पता है कि हम स्टीरियोआइसोमर्स को बॉन्ड लाइन फॉर्मूला में दिखाते हैं या सिंपल कंडेंस फॉर्मूला में भी उसको दिखाया जाता है. But to understand the conformation, we should represent this stereoisomers or conformations into Newman projection formula and Sawhorst projection formula. So first I'm going to tell you how to write these formulas. So for this we take example of ethane. So student, this is ethane. I give number, carbon number 1 and carbon number 2. Now first we're going to study what is Newman projection formula. Now for Newman projection formula, see, first we write a circle and then a dot. So circle with dot we have to give for Newman projection formula. Now this dot is carbon number 1 and this circle represent carbon number 2. So this carbon number 1 attached with 3 hydrogens, 1, 2 and 3. And this carbon number 2 also attached with 3 hydrogens. Okay, but these 3 hydrogens I have to write down from circle 1, 2 and 3. So student, this is called Newman projection formula. Now student, if I rotate this, means if I rotate this molecule or carbon-carbon single bond by say 60 degree, I get another form of Newman projection formula. So circle with dot, hydrogen, hydrogen and hydrogen. Then I have to rotate this. Due to this rotation, I get this type of structure. Now what happened in this structure? In this structure, this hydrogen hide each other. मतलब आगे वाला जो हाइड्रोजन है वो पीछे वाले हाइड्रोजन को क्या कर रहा है? It is completely hide that. So this type of hiding is called eclipse. It is called eclipse conformation. And when in Newman projection formula, when hydrogens are away from each other, it is called staggered conformation. Okay, so this is the meaning of eclipse and staggered also. Now, Sawhorst projection formula. So for this again I take example of ethane. I have to give number 1 and 2, number 1, number 2. Now for Sawhorst projection formula, we make a line. Okay, we make a tilted line Now these two dots represent carbon number 1 and carbon number 2. Now carbon number 1 attached with 3 hydrogen, so I have to write like this. Carbon number 2 also attached with 3 hydrogen, that's why I have to write down like this. So I write hydrogen, hydrogen, hydrogen on each carbon atom. Now in this case, hydrogens are hide each other, and that's why this is called eclipse conformation. So we can show staggered conformation also. See how we can show that. Okay, this is formed due to rotation of this bond. Okay, so I have to show hydrogen below side. As you can see, hydrogen and hydrogen. Now these two hydrogens are away from each other. Now this is called staggered conformation. Now students, these are the two formulas by using which we can represent conformations. Now you can see these two formulas in a single screen, as you can see here. Okay, so please remember Newman projection formula and Sawhorst projection formula. Now we start with conformational analysis of ethane. In ethane molecule, two methyl groups attached by a single bond. Now if one of the carbon atom is allowed to rotate carbon-carbon single bond, so among two carbon atoms, if one carbon is going to rotate while keeping other atoms stationary, two conformations are possible, and that are called staggered and eclipse conformations. See this. As you can see here, one carbon atom is going to rotate, and that's why we get two conformations. One is eclipse conformation where everything is hide, means front hydrogen hide back hydrogen, as you can see here. So these are the two staggered conformations, and these are the eclipse conformations. Now we can easily remember this by using, when this is rotated by 60 degree, okay, I get this Newman projection formula, or we get this eclipse conformation. This is eclipse conformation and this is staggered conformation. I already told you difference between staggered and eclipse conformation. So here also in Sawhorst projection formula, as you can see, this hydrogen, these are away from each other, but here this hydrogen and this hydrogen completely hide each other. So these are the two conformations of ethane: staggered conformation and eclipse conformation. Now, what are their stabilities? Of course, in conformation analysis, we compare the stabilities of conformations. So, staggered form has less energy and hence it is most stable conformation since all the hydrogen atoms are as far as possible. Eclipse conformation has energy due to all hydrogen atoms are close to each other and they will experience repulsive interactions. Hence, eclipse form is less stable as compared to staggered form. Okay, as you can see here in this case, these hydrogens are away from each other, right? And in this case, they are very close to each other. When they are close to each other, there is a repulsive attraction between them. They repel each other, and due to that repulsion they have a high energy because they are unstable, and that's why they are less stable as compared to staggered form. So staggered form is highly stable. Again, reason is hydrogens are away from each other and there is no repulsive interaction between them, and that's why stagger is more stable as compared to eclipse form. And these two forms we get due to rotation of carbon bond by 60 degree. Now this is the stability order. As you can see, eclipse conformation is least stable, and that's why it has a high energy. So this hump is for high energy, and this is stagger conformation, which is more stable, which has a less energy. So this is the energy diagram, and this energy diagram also tells us about which is less stable and which is highly stable. Now we go for conformation analysis of N-butane. Now this is the structure of N-butane. Carbon number 1, carbon number 2, carbon number 3, and this is carbon number 4. Now N-butane has 3 carbon-carbon single bonds, as you can see here, and molecule can rotate each of them. So due to this rotation, we get different types of conformations. But here we're going to study conformations are arise due to carbon number 2 and carbon number 3. So due to rotation of carbon number 2 and carbon number 3, we get total 6 conformations. What are these conformations? First of all, each conformation is obtained due to rotation of carbon atom by 60 degree every time. Now as you can see here, this is the rotation of carbon number 2 and carbon number 3, and that's why we get different types of conformations. So in case of here, we get total 6 conformations. Let's study their names first. First one is called anti-periplanar. Second one is called anticlinal. Third one is called synclinal. Fourth one is called synperiplanar. Then we have a synclinal. And at last we have a anticlinal. Okay, so here we get synclinal form, means this form number 3 and form number 5, these are same. So these are same, as well as this anticlinal, this form is also same. Okay, why these are same, that we going to study here. So first of all, when you rotate this bond by 60 degree each time, okay, when you rotate the carbon-carbon bond 60 degree each time, we get these different types of conformations. Now this anticlinal form, number 2 and number 4 is same. Okay, why it is same? Because as you can see here, there is a methyl group hide hydrogen. So here also this methyl group hide hydrogen, right? And in this case, hydrogen hide methyl group. So here also hydrogen hide methyl group, right? So that's why these are same. Now this number 3 and number 4 form, these are also same. Now why these are same? As you can see here, methyl groups are close to each other. Here also they are close to each other, but in a other side, right? And that's why these two are synclinal forms are same. Now first we're going to study why these are called antiform, syn form, clinal form and periplanar form. Now the conformation in which adjacent CCH3 bonds are in same plane, then they are called periplanar. Now if they are not in a same plane, then they are called clinal. If methyl groups are close to each other, it is called syn. And if methyl groups are away from each other, it is called anti. So student, this is the meaning of what is periplanar, what is clinal, what is syn and what is anti. Let's study their stability one by one. Now, this one is anti-periplanar conformation, which is about number one. So first conformation, as you can see here, this is our first conformation, and it is called anti-periplanar. Now, why it is called anti-periplanar? Now, first of all, what is the meaning of anti? If methyl groups are away from each other, it is called anti. And the conformation in which adjacent CCH3 groups are in same plane are called periplanar. So it is anti-periplanar because methyl groups are away from each other, first of all, here, and they are away from each other as well as they are on a same plane. That's why this is called anti-periplanar form. This is called fully staggered form. Now it is a fully staggered conformation in which methyl groups are as far as possible. So why this is called fully staggered? Because methyl groups are away from each other, maximum distance. Now it has a minimum energy, hence maximum stability. So here methyl groups are away from each other, and that's why there is a less interaction, repulsive interaction between them. That's why it has a minimum energy, less energy, and it has a high stability. So this is about our first form. Now number two. Number two is synclinal, which is also called gauche form, or number three and number five. So what is syn? Meaning of syn means methyl groups are close to each other. As you can see here also, methyl groups are close to each other. These are methyl groups. These are close to each other. That's why this is called syn. And clinal means methyl groups are not in a same plane. So here methyl groups are not in a same plane, and that's why these are called synclinal. So synclinal we have total two forms, number three and number five. Now in this equivalent conformations, methyl groups are closer to each other than allowed by a ordinary van der Waals radii. So methyl groups are close to each other, and due to this closeness, they have a interaction, repulsive interaction. And due to this repulsive interaction, they are unstable. So they are higher energy than fully staggered form, or in short, they are unstable. Now we have an anticlinal form. Anti meaning methyl groups are away from each other, and clinal means they are not in a same plane. So in this form, hydrogen and methyl groups are eclipse, means they hide each other, as you can see here also. Okay, there is a complete hide. They are of higher energy than gauche form, but they are a higher energy than gauche form, but lower than fully eclipse form, right? And that's why methyl group hide hydrogen. Here hydrogen hide methyl group, means there is a repulsive interaction between methyl group and hydrogen, right? And that's why there is a higher energy, and due to this high energy they are less stable. And at last we have a syn periplanar form, that is fully eclipse form. This one here, methyl groups are on the same plane, correct? That's why this is called periplanar, and they are close to each other. That's why this is called syn. So it is called syn periplanar form, and it is called fully eclipse form. Now in this form, large size two methyl groups are eclipse, hence there will be strong non-bonding repulsion between them, and therefore it is of high energy conformation having less stability. So स्टूडेंट यहाँ पे क्या दिखाई दे रहा है, सिर्फ इस फॉर्म में क्या है कि मिथाइल ग्रुप को हाइड कर रहा है, और किसी भी कॉन्फॉर्मेशन में मिथाइल ग्रुप को हाइड नहीं कर रहा है. So when methyl group hide methyl group, that means there is a higher or stronger non-bonding repulsion. मतलब repulsion बहुत ज्यादा होता है, and due to that this high amount of repulsion, there will be high energy, and due to that high energy, this fully eclipse form or syn periplanar form is least stable. So among all that, this is least stable. So again, we start with number 1. See here, anti-planar form, methyl groups are away from each other. That's why it is highly stable. In second form, methyl groups एक दूसरे के थोड़े पास आ गए हैं, ओके, एंड पास आ गए, बट किसी ने यहाँ पे कोई भी दिस इज नॉट ए इक्लिप्स फॉर्म, मतलब किसी भी हाइड्रोजन या मेथाइल ग्रुप ने दूसरे मेथाइल ग्रुप या हाइड्रोजन को हाइड नहीं किया है, राइट? That's why there is a repulsive interaction, but that repulsive interaction is not high. That's why this synclinal form or gauche form is less stable than a fully staggered form. मतलब number 1 जो हमने देखा. Then at number 3 we have a anticlinal form, because यहाँ पे methyl group हाइड्रोजन को हाइड कर रहे हैं या फिर हाइड्रोजन methyl group को हाइड कर रहे हैं. Means methyl group and hydrogen close to each other. बट यहाँ पे methyl group को हाइड नहीं कर रहा है. That's why it is more stable than fully eclipsed form. और जो सबसे कम स्टेबल है वो है syn periplanar form, this one. So when you draw energy diagram look like this. So this one is डायहेड्रल एंगल 0, ओके, जहां पे डायहेड्रल एंगल 0 है वो कौन सा है? हमारा मिथाइल इक्लिप्स फॉर्म, फुल्ली इक्लिप्स फॉर्म नंबर 4. So that's why it has a high energy and it is a least stable. We have a 60-degree gauche form, then we have a anticlinal form, and then we have a anti-periplanar form. यहाँ पे अब you can see that in anti-periplanar form it has a least energy. That's why it is highly stable.